right, so a polynomial. What that actually says is anything, any number or variable that does not have a negative exponent and does not cause division by 0 is a polynomial. So anything in math that does not have a negative exponent and does not cause division by 0 is a polynomial. Say that one more time. Anything that does not have a negative exponent and does not cause a division by 0 is a polynomial. All right. So the first one, 2x plus 4. There is no exponent that is negative, and there is nothing that would cause me to divide by 0. So is this a polynomial? Yes. All right. Problem number 2. 3x squared plus 2x plus 5. Do I have a negative exponent?
No.
No. Is there anything that would cause me to divide by 0?
No.
So is that a polynomial?
Yes.
Now, you notice these all have had plus or minus in it. Because it says a polynomial represents a monomial separated with plus and minuses. So number 3, it says 3x. Is that a polynomial?
Yes.
Why?
It doesn't have a negative.
Because it doesn't have a negative exponent,
I don't have to divide by 0.
and there is nothing that can make me divide it by 0. But the word poly means multiple. So I only have one term. Why is this also a polynomial?
Variable.
Because I can make this. Is that the same thing? So is it a polynomial? Yes. Alright, now the next one. This is the one that caused some confusion. Just the number 5. Does it have a negative exponent?
No.
Is there anything going to cause you to multiply or divide by 0, Desmond? Anything going to cause me to divide by 0? Is there anything going to cause me to divide by 0 on problem number 5 or 4? Is there anything that's going to make me divide by 0?
No.
No. So it has to be a polynomial. Now, here is why. Because this is the same as 5x to the 0 plus 0. Because x to the 0 is the same as what? 1. Since x to the 0 equals 1, 5 times 1 plus 0 is still 5. I have a variable, I have an exponent that's not 0, and I'm not dividing by 0. So yes, that is a polynomial. Alright. That's where we had some confusion yesterday. I totally apologize for that. Alright, now, let's look at this next one. 3x plus 5 divided by x. Is that a polynomial?
Yes.
Alright. Are there any negative exponents?
Nope.
No. Is there any number that I could put in there that would make that dividing by 0?
Nope.
Any number that I could put in for x that would cause me to be dividing by 0? Yes. What number would that be? 0. So is it a polynomial? No. Because when x equals 0, this becomes undefined. So when that x becomes 0, you now have an undefined. You cannot divide by 0. All right, so let's look at the second problem. X squared minus x plus 2 divided by x plus 4. Is this a polynomial? Mr. Cook, what do you think?
You say if it ain't a polynomial, you can't have a negative exponent.
Correct. Does it have a negative exponent?
Nope.
No. Okay. So that's the first one. No. So that's one check. Is there anything I can put into this for x that would cause my denominator to be 0?
Yes.
Alright? So I can make my denominator 0.
Yeah.
So is this a polynomial?
Nope.
No. No. Because when x equals what?
No.
No. What do I have to? Blank plus 4 has got to be make 0. So what plus 4 equals 0?
Negative 4.
So when x is negative 4, this becomes undefined. So you have to look at the denominators. Is there any number that I can put in for my x that would cause that equation to become undefined? All right. So that's just a quick reteach of how to identify polynomials. All right, so yesterday we talked about the addition of polynomials and subtraction of polynomials. Now, today we're going to move on to the multiplication. Multiplication is a little more difficult, but not terribly hard. So, back when you were in elementary school, you learned about multiplying. So you had a problem that said 41 times 3. So just a plain multiplication problem. So you could break that down and go 40 plus 1 times 3. Same problem. So once we got up into higher, this was how we started seeing our problems. What's it called? What is it that I have to do with that 3? I have to use the distributive property. That's the exact same thing as this. So I would go 3 times 40 is 120, plus 3 times 1 is 3, 123. Exact same thing. Distributive property. So that's the same thing that we're doing when we're multiplying polynomials. Alright. So, you can write this as an up and down multiplication if you want. Or you can do distributive property when there's one number. Either one. Easiest to me when there's only one number is to do distributive property. Just like we did way back. Alright. What number is understood to be in front of that x cubed? Desmond.
1.
A 1. Good. What number is understood to be in front of the x? A Stone. 1. Good. So you multiply your coefficients. 4 times 1 is 4. X squared times x cubed is X to the what?
Fifth.
Fifth. Because when you're multiplying exponents, you add the 2. X to the 5th minus 4 times 1 is 4. X squared times x is x cubed. 4x squared times 2 is what, Kentrail? 8x squared. Good. And that's a positive. And you're finished. So once it comes down to just multiplying, if you have one number, a monomial on the outside, to me, it's easiest to just see it as distributive property. Now, here's where it becomes a little more difficult. So when you were in lower grades, you did this problem. 123 times 45. And we put it on top. It's easier to work it this way than it is to write it out and do the distributive property. Because I have, this would be 100 plus 20 plus 3 times 40 plus 5. That just does not make much sense. Alright? So, we learned how to stack them up on top of each other and just multiply. 5 times 3 is 15. 2 times 5 is 10 plus 1 is 11. 5 times 1 is 5 plus 1 is 6. We have no 1s. 4 times 3 is 12. Carry my 1. 4 times 2 is 8 plus 1 is 9. 4 times 1 is 4. 5, 3, 15. So 5,535. When you are multiplying polynomials and it has more than one piece in both of them, it's easier to just stack them up and multiply like we did back in grade school. So we're not doing any new steps whatsoever. All we're doing is multiplying just like we did before. Alright. So when you're multiplying in grade school, you put the number on top always had more numbers. So we're going to do that with this one. The one on top, the term on top, has to have the most terms. So I've got, this one's got 3, this one's got 2, so this one goes on top. X squared plus x plus 1, and I'm going to multiply it by 2x minus 3. Alright, first thing I'm going to do, I'm going to take negative 3 times 1. This is a negative 3. Negative 3 times 1. Sandarius. Negative 3 times x. Honesty. Negative 3x. Negative 3 times x squared. Quandarius.
Negative 3 x squared.
I agree. Alright, so I'm done with multiplying this one. So I'm going to go to my 2x. So, 2x times 1. Buckley. 2x. But I put it right underneath my one that has the x. So this is a plus 2x. Not 26, 2x. Alright, 2x times x. Rachel. 2x squared. Because this is an x to the 1, this is an x to the 1, 1 plus 1 is 2. So, and it's positive. Alright, 2x times x squared. Mr. Cook. 2x times x squared is what? Okay, so you multiply your coefficients. 2 times 1 is 2. I have x to the 1 and x squared, so that becomes
Huh? Cube.
X cubed. Now, we have the exact same thing that we did yesterday when we were adding. Draw my lines to keep them. -3 plus 0 is? -3. -3x plus 2x? -x. -3x squared plus 2x squared? -x squared. 2x cubed plus 0? 2x cubed. There's your answer. 2x cubed minus x squared minus x minus 3. All right, Rashid, you got any questions? Good. All right, let's look at another problem. Quantity of x plus 1 times the quantity of x squared plus 2x minus 4. All right. Asia Hubbard. What am I going to do first? What's the first thing I got to do with any math problem? I'm going to set it up. Thank you much, Marcus. So I start, the one that has the most terms goes on top. X squared plus 2x minus 4. Now I'm multiplying that by x plus 1. Alright. So we start off with our positive 1. Alright, J. Lee. Positive 1 times negative 4. Negative 4. Darius. Positive 1 times 2x. So positive 1 times x squared. Quandarius.
Positive 1 times x squared.
Positive 1 times x squared.
X squared is 1. Alright.
1 what?
1x. Hold on. 1 squared. 1.
You're getting your words.
1x.
You're getting your words all confused. Alright, take a breath. What is it?
Times x squared, right?
Uh-huh.
Alright, so it gotta be x squared, right?
Very good.
Alright, not bad.
So 1x squared. Alright, so now, I'm going to take the next piece. X. X times negative 4. Desmond. X times negative 4. Yes, you do. X times negative 4.
Negative 5. Negative x.
We're multiplying, honey, not adding.
Oh no,
I think
Alright.
I'm good.
4 times, negative 4 times 1 is what? Desmond?
oh.
Negative 4. So it's going to be negative 4x.
She already tried
X plus 2x. Kentrail? Or x times 2x?
2x squared.
2x squared. X times x squared. Asia Stone. X cubed. At this point, Draw your lines. Solve it just like we did yesterday. -4 plus 0. -4. -4x plus 2x.
Negative 2x.
-2x. 2x plus 1x squared.
3x squared.
3x squared. And there's your answer. Alright. So at this point, everything that's on your agenda for this week has been taught. So your assignments on the agenda. Whoop, hold on. The assignments, you have 3 assignments. All 3 of these you should be able to do. Now,